Let's get our hands dirty, shall we? How about we deploy some simple pods to get familiar with the kubectl tool and the commands available to you. Our very first command is going to be to deploy a pod with the nginx container in it. To deploy an nginx pod, let's run kubectl run the name of our pod, which we'll call nginx, -- image, and the name and version of our image. That's it. It looks a lot like a Docker run command, doesn't it? We get a response back that the pod was created, and we can now run kubectl get pods to list the pods running in our cluster. Since our status shows container creating, we'll wait a second and try that command again. Eventually, the pod should show that it's in a running status. Congratulations, you've just deployed your first pod. Now sometimes we need more information about those pods. To get more details about this pod, you can run kubectl describe and then the name of the pod. The describe command gives you information about what happened during the deployment of the pod and details such as statuses, IP addresses, etc. We can also find some additional quick information about these pods by running kubectl get pods again with the -o wide switch, which will show us the IP address and nodes, which are often helpful for troubleshooting. Time to delete that pod and try something else. To delete a running pod, just run kubectl delete pod and then the pod name. If we check our pods list again, you'll see we have nothing else running. Now the first command we ran were imperative commands that tell the API server what you want to do. We can also use a declarative YAML file and apply that instead. So let's deploy another pod, but this time we'll apply a YAML file instead of specifying everything in the command line. If I do an ls, you can see that I have a YAML file created already called myfirstpod. And if you look at the YAML file, you can see that I've given the pod a name called myfirstpod, and the container within the pod is nginx version 1.22.0, and we're exposing port 80. To deploy this pod, we just have to run kubectl apply -f, F stands for file, and the name of the YAML file. You can see you get those same results here as you do by running a kubectl run command. When we want to delete the pod, we can also reference the file we used to deploy it. So we can run kubectl delete -f again for file, and the name of our YAML file. This does the same thing as running a kubectl delete pod and then the pod name. For the next example, I've added a second terminal window so we can try using a watch command. In previous examples, we needed to run a kubectl get pods periodically to check on the status of those pods. We can also use the --watch switch, which will allow us to see any changes to our pod statuses as they happen. Let's try it. We run kubectl get pods --watch, and then we'll go to our other terminal to run some other commands. I'll run kubectl run ubuntu --image equals ubuntu, and then sleep 300. This tells the API server to run a pod named Ubuntu from the latest Ubuntu image and to have it sleep for 300 seconds. When we run that, you can see our watch screen is showing us the status of those pods as they change. This way we don't need to keep rerunning kubectl get pods all the time. Now that our pod is running, let's try to get into the pod. This is used for troubleshooting purposes most often, but you never know when you're going to need to access the inside of a container that's running. We can run kubectl exec -it for interactive terminal, the name of our pod, and then --bin/bin/sh as the command we want to run inside the container. You can see we get a command prompt here, and if we run hostname, we're now getting the hostname of the container that's running. We can do an ls to see the file system, and if we run ifconfig, ifconfig isn't part of the image. You see, we remove unnecessary things from container images to make them smaller, and most people won't need this command for a container image, so it's been omitted. We can still do things like run apt update on this container, but remember, as soon as this container restarts, any of those updates will have been removed. So every container might be a little different, and the commands you might have available to you are also a little different. Let's delete that pod for one more example. And as we do this, you can see the status is updating in the terminal on the right side of your screen. What if we want to run that same pod again, but this time we don't specify any sleep command? You'll notice that the pod has a completed status and then changes to a crash loop backoff status. This means the pod is going to try again because there is no process to run like before when we asked the container to run the sleep command. So the point here is to let you know that containers will run until their process completes either successfully or due to a failure. Since this container didn't have anything to run after it started, it was restarted. Hopefully these examples that we've gone through together today have been useful. You're going to get a chance to run these commands on your own in the labs. Have fun. We'll see you next time.